Hello and welcome to the Algebra 2 final review via video. So I'm going to go through this PowerPoint that I created to help you guys recall and remember what we have learned this entire semester. So let's get to it. The first part was Unit 1, and we're going to look at Unit 1, Part 1. So if we look under that Unit 1, Part 1, which probably seems like it was forever and a day ago, the first thing we really talked about was simplifying a radical and solving quadratics using one of the four methods, okay? Now, I'm just going to very quickly go over why we simplify a radical and an example of it. So, to simplify a radical, you have to break down the number inside and underneath that square root and find factors or pairs of numbers that we can pull out and put to the outside. The first example we're going to look at is the square root of 96. Okay? Now, I don't have a calculator on me. I don't have anything like this. What I'm going to do is use my brain power and logic to figure out what I can do. So, if you don't have anything like that at home, the first thing you can notice is that it's an even number. Okay? When it's an even number, you can always divide it by 2. So I'm going to start off with dividing this by 2. So 2 into 96, 2 times what number will give you 96? Well, you got to divide. That becomes 4, carry the 1, that's 8. So at this point, 48 is a more manageable number. I kind of know what I'm doing with 48. So I'm going to use the numbers 6 times 8. 6 can be simplified down to 2 times 3, and then 8 can be simplified to 2 times 4. Now, I apologize since I'm running out of room, but 4 can be simplified down to 2 times 2. At this point, we have to find everything that is a pair, okay? So, we have a pair of 2's down here. We have a pair of 2's right here, and is there any other pairs? No. What we have left is simply, let me see if I can change colors, this 3 and this 2. So what do? Well, we pull out the 2's. How many pairs do we have? We have 2. So what you can do is multiply. What is 2 times 2? Oh, Miss Smith, it's 4. Yes, very good. Now we have what's underneath here. Okay, what goes underneath my square root symbol? What is 3 times 2? It's 6, okay? So that is what would go under my square root symbol. So the square root of 96 is simplified down to 4 root 6, or 4 square root 6, excuse me. All right, and that's how you simplify a radical. If you need more help on that, please see your teacher. After we simplified radicals, that little piece of information, we solved the quadratics, which I hope at this point in time you know what a quadratic is. If you do not, just as a reminder, standard form for quadratic is ax squared plus bx plus c. The degree of 2 tells you that it's a quadratic. This is the standard form for it. And that is what we use as the basis of understanding all of it, okay? In order to solve said quadratics, we can factor. We can use taking the square root. We can use completing the square. We can use quadratic formula, okay? Now, after that, we looked at the discriminant. The discriminant recall is, and I'll get into this more later, is simply what's underneath the square root symbol in the quadratic formula. What is that, Miss Smith? Well, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? That will be given to you on your final exam. However, I highly encourage you to know it. My students, you better know it. Okay? I expect you to know it. I want you to know it. Memorize it. Live and breathe that. So the discriminant is simply the stuff underneath the square root. B squared minus 4ac. What does that tell you? Well, if that is positive, you're going to have two real solutions. I don't care what positive number it is. If it's a positive 1,562, you know you're going to have two real solutions. If you get, miraculously, a 0 with that underneath that for the discriminant, if you get a 0, you will have one real solution and one imaginary solution. Okay? That's very rare to occur. I have seen it happen. It does happen. But just know, if you get 0, it is one real solution and one imaginary solution. Now, the only other thing we're left with is when the discriminant is less than 0. What does that mean, Ms. Smith? Oh, it means that all of your numbers are negative. Okay? All of your solutions are negative. If you get a -1, a -100, a -4, you're going to have two imaginary solutions. Again, we'll get into that more later. And then the final thing was basically putting all this together with those imaginary solutions. You guys have done this. We have utilized these quadratics over and over again with Unit 3, Part 1. We have utilized this 1,000,005 times. I don't know how else we can reiterate this, but we will go over it just in case. Now, the next slide, let me exit out of that. The next slide, we are going to talk about and go over the 4 ways of solving these quadratics, okay? So factoring, this right here, this x squared plus 5x plus 6 can quickly be factored to, oops, sorry guys, can quickly be factored to 2 sets of parentheses, x. What are 2 factors of 6 that will add, when added together, will give you 5? X plus 2 and x plus 3. If you said that, you're in good shape, okay? Different teachers had different ways of telling you and teaching you this. At this point in time, if you would like to direct your questions to your teachers, please ask your questions to your teachers about factoring. The next method is the square root method. You use this method when you're either in vertex form or you're missing your b of x term, which your b of x term is the middle term, just as a recall. What do? Well, your first step is to move your 100, that -100, to the other side. So I'm going to set this equal to 100. And then after this, what you're going to do is to divide 5 from both sides. So we have x plus 2 squared equals 20. Take the square root of both sides. This becomes 1. X plus 2 is equal to plus or minus the square root of 20. One of the most common questions I was asked was, why do you put the plus or minus in front of your square root symbol? Well, ladies and gentlemen, you are solving for x, correct? So whenever you are solving for an unknown variable and you're taking the square root, the cubed root, the fourth root, whatever what have you, you have 2 solutions, okay? Two different things to look at. You have the positive the positive square root and the negative square root. So you always have to remember, when solving, you add the plus or minus. Now, at this point, I'm going to go ahead and make it smaller, potentially, and see about maybe rewriting it. I'm going to rewrite it over here. X plus 2 equals the square root of 20, okay? We have to simplify that 20. What 2 factors do we have? 4 and 5. 4 is 2 times 2. That's a pair. We can pull it out. So I'm going to go ahead and move the 2 over. I'm kind of combining steps. -2 plus or minus 2 root, what? 5. Okay, so I'm going to go ahead and erase Don't freak out. You can pause the video at any time and go back and look at my steps. I'm going to come over here and say the solution to this square root method is -2 plus or minus 2 root 5. And that's my solution with my square root method. Oops. Now, the fourth method, the fourth example we're working with is completing the square. Why do we use completing the square? Well, if you notice, the leading coefficient is 1, which is perfect, and the b term is even, okay? So, since those two qualifications, I'm going to go ahead and what's my first step? Well, it's to move this positive 57 over to this right side. X squared plus 14x. Now I know some of you like to go ahead and add in those blanks. Equals -57 plus, add in that blank. What you do to one side, you must do to the other. In that blank is going to be half of b squared. Half of b, I tell my students to go in this little box over here, which is your work box. Half of b is 7, and then 7 squared is equal to 49, okay? So I'm going to put 49 on both sides. So this, if you remember your identities, which I know that's hard for you to do, listen, we all struggle. This is a perfect square trinomial. This was why we did completing the square. This is very important for you to kind of sink in, soak it in. We know we can use that special identity to simplify this quickly. How? Well, we get a parentheses and we get it squared. What's the square root of x squared? X. Okay. And then what's the square root of 49? 7. The b term tells you what sign you're going to have. That's based off of that identity we learned in the next couple of units. That's where it is. So since it's positive, since it is a positive number, we will take that plus sign and put it in between those two variables. Okay? So x plus 7 all squared is equal to, now we got to do a little math, -57 plus 49. I have to do it in my head. That gives you -8. I gotta make sure. Sorry, you guys. Yes. Okay. Now, at this point, we're going to take the square root of both sides. Now, I'm kind of getting ahead of myself, but that's okay. I wanted to kind of show you and expose it to you now, so we don't have to reiterate this later on. This becomes x plus 7. Why? Because that becomes 1. Based off of the square root method, we have a negative symbol. What does a negative symbol mean under a radical? Or excuse me, a square root? Well, it means that we have an imaginary number. So we have to bring out and bust out that I. Okay? So we have plus or minus I root 8. Now, the next question becomes, do we simplify 8? And the answer is yes. 8 can be simplified to 2 root 2. How did I know that? 8, okay, this plus or minus I root 8 is 4 times 2. 4 can be broken down into 2 times 2. This is a pair which can come out. Now, a big question is always, how do I write that? Where does the I go? Well, how do you know? The I always goes in front of your square root symbol, but behind your coefficient. So, I'm going to come over, and I'm going to erase my little notes box. I'm going to do what I did before. I'm going to come over here and write that. X plus 7 equals plus or minus I. Okay, wait, I did this wrong. We simplified it. My bad. 2I root 2. Okay, so now I'm going to move the 7 over by subtracting it to both sides. X is equal to negative 7 plus or minus 2I root 2. And that is how you do completing the square. Those are your two solutions. Okay? All right, last but certainly not least. Let me go ahead and erase, is quadratic formula. Now, the majority of you really enjoy quadratic formula. Why? Because it's straightforward. It is a formula that all you have to do is plug and chug. Okay? I know you get tired of hearing that, but it's the truth. When all else fails with the quadratic, you can always count on the quadratic formula to come in. Okay? It can always come into play. All right, I'm just going to rewrite this solution right here so that we have it. The quadratic formula tells you, just in case you don't remember it, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac. Now, common mistakes is you don't carry over this division line. It has to be over everything, okay? It has to have 2a on the bottom of all of your numerator. Don't make it just over or underneath the square root. No, you have to make sure it's extended over the entire line, okay? So, in this equation, this is my a, this is my b, this is my a, this is my b, and this is c. All right, that was the standard form of a quadratic. So all I have to do is plug it in to my formula. Negative b. If you notice, we have a negative 15. Well, the negative of a negative 15, it becomes a positive. We got to just change the sign. 15 plus or minus the square root of negative 15 squared. Please notice, okay, please notice that I put negative 15 in parentheses. You have to put your symbol in parentheses because if you do not, when you go to put in your calculator, you're going to get it wrong. It simplifies incorrectly. Whenever you square a negative number, it becomes positive. But it won't do that unless you tell the calculator to do that specifically. So, I'm going to continue on. Minus 4, what's my A? A negative 3 times my C, which is a positive 33. At this point, I'm going to pause real quick and get my calculator. I'm going to finish writing this though, 2 times a negative 3, and I'm going to go ahead and do some math. So I'm going to pause. All right, so I'm back. 15 negative 15 squared is 225. Now, I notice that I have a negative 4, negative 3, and a positive 33. So I'm going to add 12. I'm going to add the second part. Negative 4 times the negative 3 is a positive 12. And then times 33 is going to be everything that's underneath that square root symbol is 621. Okay? So I'm going to erase because I don't have a whole lot of room left. And I'm going to put 621 underneath my square root symbol. Okay? So now we got to do some math and simplify 621. I know that's a big number. We're going to give it a shot. Now, notice 621 is an odd number. So the numbers that I'm going to try, this is odd, so it's an odd number. The numbers I'm going to try, the first one I'm going to try is 3. And it works. So 3 times 207. I'm going to do 3 again and see if it works. It does. 207 simplifies down to 3 times 69. And I'm going to divide by 3 again. 3 times 23. All right? So we have a pair of 3's. And then we have this. 23 is a prime number, so I cannot simplify that anymore. Okay? So now I have 15 plus or minus 3 root 23. On the bottom, we have -6. Are we finished? If you answered no, then you're correct. We have to simplify. At this point, we're going to take this whole entire thing and divide by 3, okay? Every one of those terms, this coefficient right here, this constant, and your denominator, we're going to divide everything by 3. Now, again, I am running out of room, so I'm going to erase my simplification, and I'm going to put it over to this side over here. This becomes 5, 15 divided by 3 is 5, plus or minus the square root of 23, 3 divided by 3 is 1, all over -2. So, I'm going to erase this. And put this down here. 5 plus or minus the square root of 23 all over a -2. Now, some people might get nitpicky about a negative being in the denominator. When you're in college algebra, pre-calc, I'm not sure exactly what other math classes, but higher math classes, if you would like to, you can take this one step further and move this -2 to the numerator. How would we do that? We would simply bring this up, keep the 2 on the bottom, and this would become a -5 plus or minus the square root of 23. We are able to do that because of your negative rules, okay? Now, this should technically be in parentheses, okay? This method we accept. I accept. I know I've talked to my students a little bit about rationalizing and making your denominator real and stuff like that, and moving those negatives around and making sure we satisfy those rules. But we have accepted this answer right here, okay? All right, you guys. Now, since we are on the topic, let's talk about the discriminant. For this one right here, okay, we didn't use quadratic formula. We really only used the quadratic formula for this last one right here, okay? Let me change back right here. We notice that this is 23, okay? So for this quadratic formula right here, how many solutions will we have? We will have 2 real solutions. Since it's a square root and we don't have a perfect square, it'll be 2 irrational solutions, but we will have 2 real solutions, okay? If you have questions, please ask your teachers, please ask me. But if you're good, so far so good, hopefully this was a brief recall for you guys, all right? But that was the 4 ways to solve quadratics with the I, okay, the brief lesson of the I, and I think you guys are good. That was Unit 1, Part 1.